Hello, my name is Vasilis.
And I am Evangelos Nikolaou, and together we have built Overlord, a tool which automates infrastructure setup on the cloud. The tool is mainly used for red teaming engagements, but it can also be used for simple social engineering or other smaller scale attacks. So let's start with a very simple example of what it is a command and control server and a redirector, because they are the main components of a red teaming infrastructure. Command and control server, or C2, is a server which is controlled by the attacker and it's used to send commands to compromised systems. The redirector is another server which is directly connected to the C2, for example via socket, and basically it hides the presence of the C2. So here we can see a full red teaming infrastructure example which can include multiple command and control servers with their redirectors. We have a mail server, a phishing server, which can host the phishing website, for example, payload server, which can host our payloads to be downloaded, etc. All the servers shown here are under the control of the attacker, of course. So to make sure that only the needed services are accessible over the internet, we use firewall rules in each of the cloud providers. So AWS and DigitalOcean, which are used by Overlord. For example, as we can see here, we have a DNS C2 with only port 53 open from the inbound and the port 22, which is only accessible to the public IP of the pentest team. And of course, it's for management purposes of the server. The outbound rules allow the HTTP ports for downloading tools and scripts, as well as the port 53 to perform domain resolves. If the C2 was an HTTP one, we would need also in the inbound port 80 and 443 for the compromised systems to connect to these ports. So now that we have finished with the red teaming basics, let's talk about Overlord. Overlord was inspired by Red Baron, which is a Terraform implementation for red teaming infrastructure automation. The difference between the two is that Overlord abstracts the user from the Terraform implementation and provides a user-friendly CLI to achieve that. But at the end of the day, it's a Terraform code generator, which creates the Terraform files in the back, which are then executed and the infrastructure is created automatically. So why would someone use Overlord? Why do we use it? So first of all, it's because we are lazy. We like repeated processes to be automated. Also, it's easy to use and sets the infrastructure up in minutes, including all the servers and the DNS records and everything that the user wants to set up. Another very important component is the project management. The tool has the functionality of saving the state of a current project for any future use. For example, you can set up exactly the same infrastructure for a client in the future by using the project folder of the specific client. The tool is customizable. We have built the tool in such a way to be easily scalable and extensible. So a developer can extend the project with new cloud providers, for example, or new modules if they see a need. And finally, Overlord is reducing the cost for a company because you can destroy the infrastructure which you have deployed in again in a very short time and with one command. This will avoid any unintended costs of servers deployed on the cloud and left there by mistake after the engagement has been completed. Okay, so let's now dig into the modules offered by Overlord. Each module has a specific purpose, and we have the servers side and the rest of the modules. Let's start with the servers. So first of all, we have the C2 servers, which are the command and control we have already explained. Then we have mail servers, which we use iRedMail and postfix to configure a secure solution of a mail server. So we make a lot of configuration changes in the deployment. The web server, which is essentially a server with AT and 443 open. The redirectors, which must be connected to C2 servers. And finally, we have GoFish, which is a module which fully installs and starts the GoFish service on a specified server on the cloud. The user can then use the IP provided to log in to the web interface via port 3333, which will only be accessible from the IP where the infrastructure was deployed from, the public IP of the pentest team, essentially. The rest of the modules are used to complete the infrastructure. So we have the DNS record module, which it deploys DNS records on the provider where the specified servers reside. The Let's Encrypt module has 3 different implementations, which one is for GoFish server, web server, one is for a generic web server, and one is for creating the .pem file to be used on SE2, for example. Then we have the Ansible module, which is one of our new features. Ansible is used with custom playbooks, which are created by the user. The YAML playbooks can be used to perform actions on any of the deployed servers and installations, of course. And finally, GoDaddy is used to redirect the name servers to the provider where the DNS records will reside. So, for example, if you have a domain registered on GoDaddy and you create a C2 server on AWS with an A record on that domain, you have to use the GoDaddy module to redirect the name servers to AWS. Okay, so this is especially helpful for Route 53 because the name servers are different every time you deploy an infrastructure. So Overlord will wait until they are determined, and then it will change the GoDaddy entries to the AWS generated name servers. For DigitalOcean, the change is also done automatically by Overlord, but the manual change is also easy because the name servers are the standard NS1, NS2, and NS3.digitalocean.com, which can be done easily manually as well. It should be noted here that if you use a DNS C2 and you have to manually change the host names of the name servers to point to your own domain, this is not done by Overlord. Okay. Okay, so now that we know how the tool works and what it can do, let's see the structure of the folders and files. First of all, the config.json file includes all the necessary information such as default values. For example, we have the DigitalOcean as our default provider, which means that whenever we have the provider variable in Overlord, it will be populated with the DigitalOcean value. You can, of course, change that and amend it to your needs. The variables.json file includes all the API tokens and keys to connect to the providers. The scripts folder contains some scripts and tools which we have created to run on specified servers. For example, the GoFish implementation is located here, as well as the installation of Metasploit and DNSCAT. The playbooks are the YAML files created by the user to be used on specified servers. Overlord will load all the files from this directory to the playbook variable in the Ansible module, which you will see later when we demo the tool. Then we have the project directory, where we have the SSH keys in the folder, where all the SSH keys of the deployed servers will be stored. From there, you can log in to all the deployed servers. And then finally we have the certificates folder, which is used to store the .pem certificates in case that the Let's Encrypt module is used. Okay, so I haven't mentioned it previously, but Overlord was presented for the first time last October in Cyprus. When we submitted to Black Hat, we promised a major upgrade with new features. So the new version now includes the Ansible module, which is used to load the YAML playbooks and install anything the user wants on servers. Based on that, we have created a playbook for user management. This playbook creates different users with different SSH keys on servers and also enables logging. In case a client has a question for specific actions that we have performed, we can go back and find out what happened. Another request that we had from users was the implementation of an internal C2 redirector. So this redirector is basically pointing to an internal C2 server instead of one on the cloud. So this is done by AutoSSH and it supports HTTP and DNS. We also upgraded all the modules from Terraform 0.11 to 0.12. And finally, we now support new Linux distributions. We only supported Debian on both AWS and DigitalOcean. Now we support Kali and Ubuntu and Debian on AWS, and Ubuntu and Debian on DigitalOcean. Okay, so finally it's demo time. Vasilis will show you the tool, but before that I will show you what is the infrastructure that we are going to set up. So we are going to set up the following infrastructure. We have one HTTP C2 with its redirector on AWS and a certificate on this domain. Then we have one internal redirector on AWS which points to an internal C2 where the attacker in the attacker's internal network. We have a Gofish server with its redirector and again with a certificate on this domain and on the Gofish web server. We have one mail server and only the client of Gofish is allowed to send mails via the mail server. We have another HTTP C2 redirector for the same C2, but it's on DigitalOcean, so we have one on DigitalOcean and one on AWS, redirecting both to the same C2. And on our command and control server, we use the user management Ansible module to create two different users on the same machine. Okay, so let's start with the demo, and Vasilis will show you how the tool works. Thank you very much.
Typing help, you can quickly find out more information about each command. With the info command, you can see your keys, domains, and created modules. So let's add our Kali machine on AWS with Metasploit and one redirector. Overlord has autocomplete functionality, so you can double tap to see the available options. To add an additional redirector on the same C2, we can use the redirector module. This comes in handy when you want to spawn up the redirector on a different provider than the C2 server. One of our new features is the ability to create a redirector that points to an internal IP. This can be done by using the localhost value on the redirector ID parameter. Next, we set up a Gofish instance and its redirector on DigitalOcean. After the Gofish module is added, we can set up our mail server. Due to the customized configuration that we created for the mail server, at least one allowed IP has to be added with the set allowed IPs command. This will change my network's value in postfix and the access control list in a REDMAil configuration automatically. We have added short descriptions next to each of the modules IDs to make it easier to identify the correct instance. The info command can also be used to check the configuration for each module, as we can see in our screens now. As mentioned before, to make the tool more scalable, we have implemented the Ansible module. Using the set playbook command, we are going to use the user management script, which generates and adds our own public keys to the C2 server. The script also enables bash and tmax login. Now it's time for the hard part. We need to create all the DNS records for our project. We are going to add an A record on our own C2 server. On AWS, to set up the record, we have to use the set record command, specifying the module and the domain name. We will be fast forwarding the remaining DNS record because it's the same process for the rest of them. We support 3 types of records: A, TXT, and MX. We encourage you to check our wiki for more details. Another tip is to take some time to visualize your setup before adding your DNS records with Overlord. As we can see, the DMARC and SPF records are predefined as templates, making the process a bit easier. If your DNS provider is GoDaddy, you can redirect your domain names to DigitalOcean and Route 53 respectively. Overlord will automatically add them to the correct provider based on DNS records. Now, with everything set up, let's deploy our infrastructure. As we can see, when the deployment is finished, we are greeted with all the IPs and commands we need to know about our infrastructure. Using the remaining command, we can change the name of the project. We suggest deploying the certificates after creating your infrastructure. Otherwise, you might get the serve fail error from your name server. Creating and deploying the project again will add the additional modules to our campaign. And now we are finished with the installation. Our project folder contains all the SSH keys and certificates Overlord generated. Authenticating to GoFish server's root, we can download the password which was automatically generated for the web interface. As we can see in our screen, Overlord has generated all the necessary commands for us. Now let's test if our Ansible playbook ran correctly on our C2. We should be able to use my personal private key to log in with my username on the Kali machine. One note to have in mind is that the mail server needs a reboot to work properly. Let's log in and reboot the machine. And finally, let's use our internal director. I'm going to add a streak on my index.html file and spin up an HTTP server for our demo. As we can see, all the DNS records have been set up correctly for the Overlord red domain. Our retailer director worked as intended, and the GoFish and Red admin instances were successfully installed. Finally, the certificate for the web.overlord domain was successfully uploaded to the web server.
Thank you for joining us, and we hope you enjoyed the presentation and the demonstration of our tool.